All right, so in class the other day we finished the first part of our 5.1 notes. So we're going to finish up the back side, and there's a couple things I want to go over in case you were not in class. We took a look at radicals and roots, and you'll find this answer key that you see in front of you on Canvas. But I want to make sure that those of you that were not in class know how to use your different root buttons. So if and I'm just going to kind of review what we did in class. If you are using the cube root, and this was on the front of our notes, you're going to go to your math button and you're going to scroll down to that cube root sign, as you can see I'm doing. And we just typed in 216 and we got our root. And then to check it, the inverse operation is to go back. So 6 to the third power is 216. Okay. We did number 2. If you want to do the fifth root, you're going to need to type in what root you want first. So you're going to hit 5, and then you're going to go down to option 5, which is kind of like your generic root key, and you're going to type in the fifth root of 3125 and press enter. So the answer was 5. If you have an older model, it won't put the 5 as a small number. It'll just keep it big, but that's okay. Don't let that worry you. Just press equals, and that will give you the root. Okay. One of the things that you're going to see as we move on, so this is the back side of the notes, is there are some things I'm asking you to do without a calculator. So don't cheat and use your calculator. Then you're going to struggle when you won't be able to use it. Okay. All right. So rational exponents. Rational, we kind of think of fractions. So it says the numerator of our fraction m, and it says the denominator n represents the root. So a to the nth power is the same as the nth root of a to the nth. So you're writing it without that fraction so that you can actually work it out. Now the root, notice, goes here. So think about the denominator, think about roots. They're in the ground, they're on the bottom. So on the bottom of your fraction, that is your index, or what we call our root. So there's really nothing for you to do here on these 3 examples. It's basically a matter of just understanding that x to the 1/2 is the same as the square root of x. Now remember, you don't see a 2 there because that's square root, and a lot of times you're not going to see x to the first, you just see x. 9 to the 1/2 is the same as the square root of 9, which is 3. So anything to the 1/2 power is the same as the square root of that value. And then x to the 2/3. Notice the denominator, or the bottom of your fractional exponent, is your root. And then we have the cube root of x squared. So all they're wanting us to do in these examples is to write them in radical form. So that means we do not want a fraction as our exponent. So if we follow what we did up above, when we kind of follow this formula, we have x to the 2/5. So that would be the same as the fifth root of x squared. Now I also want you to recognize that you may see it look like this also, the fifth root of x all to the 2nd power. And these are the same thing. And if you don't believe me, we can take a number, and I'll just kind of show you that if you were going to do, I'm going to use 3. Let's use 5. If I do 5 to the 2nd power, and then I want to take the fifth root of it, so I have to go to my math menu. So I want to take the fifth root of our answer. We get 1.903 whatever. If I want to then do it out of order and do it this way first, or I should say a different order, not out of order, then I could take the fifth root. Remember, I let x be 5. I could take the fifth root of 5 and then take that to the second power, and you'll notice I'm still getting that 1.903. So the reason that some students like to do it this way is that if you don't have a large number, it might be easy to square first and then take the fifth root. But if you have a number that you can go ahead and take the fifth root of, it might be better to do it that way. So I don't want you to feel like either one of these is different. Those are equivalent expressions, just written a little bit differently. So for number 10, we would do the 2 is our root, so we would do the square root of 16 all to the third power, or that would be the same as the square root of 16 to the third power. Once again, it doesn't matter, but here's the thing. For me to do 16 to the third power first underneath the radical and then take the square root, I can't really do that without a calculator. I just don't have that memorized. But I know that the square root of 16 is 4, and then 4 times 4 times 4 is going to give me 64. So that's why we're kind of giving you options there, okay? This next one is the fourth root of a to the seventh. We can't do anything in there because we have a variable. The next one, I'm going to take the fifth root of 32 to the third power. Well, the fifth root of 32. Now, I guess I'm done there. Okay, we didn't really have to write this out. All it's asking us to do is write it in radical form. So this is technically written in radical form. I just think it's important that you know that you can go on from there. So the fifth root of 32 is 2, and then 2 to the third power would be 8. But since it doesn't ask us to evaluate it, I guess I shouldn't, but you kind of know where we're going from here. And then finally, 9 to the negative 1/2. Well, our root is a 2, so that is the square root of 9 to the negative first. And remember, if it makes you feel better to put that 2 there for the 2 root, you can, but it's not the expectation because we don't see that. Okay? All right. Now what we're going to do is we're going to go in reverse. We're going to write the expression that's written in radical form as an exponent as a fraction. So remember, right now this is the cube root. So it's really easy to remember because when I write this as y to the 2/3, I knew that the root, just like roots in the ground of a plant, go on the bottom. Okay? This would be x to the negative 5/4. Here it would be x to the 3/5. And finally, we would have x. Ooh, we got to be careful here, okay? So what I'm going to do is I'm going to go ahead and leave this 2 on the outside because this is a 2. So this would really be x to the 4/2 to the second, which would be x to the second because 4 divided by 2 is 2 to the second, and x squared times x squared is x to the 4th. So just be careful, they're kind of tricking us there a little bit, okay? All right, now, as I kind of mentioned at the beginning of the notes, it's important that it says to evaluate these without a calculator. So no one expects you to be able to do 25 to the 3/2 in your head. That's not our goal. That's why we learned up here how to use radicals, because a lot of these you're going to know. So here's what I suggest. As soon as you see 25 to the 3/2, I would write that in radical form. So remember, that is the same, our root is 2, as the square root of 25 to the third power. So the square root of 25 is 5. So 5 to the third power, we expect you to be able to do in your head. So 5 times 5 is 25 times 5 is 125. This right here means you've evaluated this expression, okay? What you may want to do is pause the video, try the last 4 on your own, and then come back and check them, okay? So you can pause, go at the pace that you need. So number 19, this would be the cube root of 27 all to the second power. Well, what times itself 3 times gives us 27? Well, that's 3, and then 3 squared is 9. So I think you're kind of catching on to why you don't need a calculator. Be careful here. We would be taking the 4th root of negative 16 to the 3rd power. Now, here's what you need to know. Is there any number that when we multiply it by itself 4 times going to give us a negative 16? And we talked about this on the front of our notes. No, there will be no real root. So here we're going to write there's no real answer. Okay. All right, but on number 21, the reason this one's a little bit different is I do this a lot in examples is to show you that here we're taking a negative 16 to the 3/4. But in number 21, we're doing the opposite of 16 to the 3/4. So our base is only 16. So what I do is I kind of keep that negative, and then I kind of inside these parentheses are going to rewrite 16 to the 3/4 in radical form. So that would be the 4th root of 16 to the 3rd power. So I still have this negative out front. The 4th root of 16 is 2. Still have that negative. 2 to the 3rd is 8, and negative times 8 is negative 8. So just kind of keep everything consistent and aligned. And then finally, your last example in your notes is you are going to do 64/25 to the negative 3/2. And there's a couple different ways, but instead of worrying about that negative first, we got a square root. So I am going to do, or I should say we have a 2 in our denominator. So the root is 2, and the negative 3 would be our power. So we're going to take the square root of 64/25 all to the negative 3rd power. Well, the square root, what times itself gives us 64/25, and that is going to be 8/5. Now we want to take that to the negative 3rd. Remember from our previous intro, our review of exponents, a negative exponent is going to cause a reciprocal of this base. So the way that you can write this without a negative exponent is positive 5/8 to the positive 3rd. So we just did the reciprocal, and that's where that negative helped us. Now you have to know that this means 5/8 times 5/8 times 5/8, and that's going to give you 125/512. So what you're going to do now that we've wrapped up our notes, use them to help you, is you have an in-class practice. And on that in-class, even though we're not in class, we're remote, normally if we were together, I would have you do that, and then we would check it before you go on to the homework. What you're going to do is that in-class practice. If it says don't use a calculator like these down here, don't get comfortable. Because if you're cheating with it, when I ask you to do it in class without it, you're going to fail that. So be careful. And you're going to be submitting that in-class practice. Follow that agenda, and then the assignment worksheet 5.1 goes along with these notes. All right, thanks.